right, good morning, class, or maybe good afternoon, depending on when you're watching this. But today we're going to talk about applications using right triangle trigonometry. So whenever you hear them talk about elevation, or when we get to the other side of the page, depression, angle of elevation or depression, that is going to tell me, all right, trig. So first type is angle of elevation. So if something is elevating, what is it doing if it's elevating? It's going up, right? Kind of like an elevator or an escalator can go up, right? So it says, when looking up to an object, the angle of elevation is formed by the observer's line of sight. So if you look straight ahead, this is your line of sight. But if you look up at something, you now have an angle of elevation. So if this person's looking straight ahead at the middle of the lighthouse, but then looks up so many degrees to see the top of it, that's elevating. So now my new line of sight is looking at the top of the lighthouse, right? Old line of sight to my new one. Am I looking up? Eventually we'll talk about looking down. So it says, draw and label a diagram. Important. Then solve for the missing part, round to the nearest tenth. So I'm going to work out number 1 and 2 with you. Have you try 3 and then show you what it looks like. And have you try 4 and see what it looks like. And do a similar process with angle of depression. So for number 1, Casey sights the top of an 84-foot tall lighthouse. All right. I'm not going to draw a lighthouse. You know my drawing. So I'm just going to draw a line. So this is the lighthouse. All right. And if I had more space, I actually would draw it. But it's 84 feet tall. And it says that Casey is sighting the top of a lighthouse. So Casey is over here. And he is looking at the top of the lighthouse. That's where he's looking. But his typical line of sight is straight ahead, right? So if I'm looking straight ahead, I see the lighthouse. But now I'm looking up at the top of the 84-foot tall lighthouse at an angle of elevation. So it does tell me I am talking about looking upward. So I'm looking upward 58 degrees. Okay? If Casey is 6 feet tall, so Casey is 6 feet tall, how far is he standing from the base of the lighthouse? Base means bottom. So the bottom of this right triangle is right here. All right, 84-foot tall lighthouse, 6-foot tall Casey. His line of sight, typical line of sight, to now looking at the top of it, he's looking up 58 degrees. How far is he from the lighthouse? Well, now if I look at this, I have what I need. However, this line I drew is 84 feet. But how do I find, if I erase this, how do I find what this length's supposed to be? Okay, the whole thing's 84. How do I find just the leg of the right triangle? Well, if I look, Casey is 6 feet tall. If he's 6 feet tall, then I'm going to do 84 minus 6, and 84 minus 6, you get 78. So this is what I have to work with. Okay, part plus part equals whole. The whole thing was 84. Part plus part equals the whole 84. That helped me find this missing part of the triangle. Now here, it just goes right back to what we've been drilling and doing over and over. My angle of elevation, I label my opposite. There's nothing for hypotenuse, so that's not going to be used. Last side is adjacent, so I have O and A. And what do we use if it's O and A? Tangent. So it's tangent of our angle of elevation equals the ratio. So now I have opposite over adjacent, TOA. And I'm finding a side, so I put it over 1. Since x is on the bottom, let me just focus a little, there we go. If x is on the bottom, when we cross multiply, you would do 78 divided by your trig function. So Casey is about 48.7 feet away from the lighthouse. That was 84 feet tall, but we needed the 78 for our right triangle. All right, so the key of the matter is drawing the picture, but then it goes right back to what we've been practicing since last week, late last week, okay? So let's try out one more and then have you try one. So number 2, I'm getting ahead of myself. It says the angle of elevation from a kicker's foot on the football field to a top of the goalpost. So I have a football kicker. He's gonna kick it up in the air. Gonna kick that football up, pretend that's a football, to the goalpost. All right, so notice though, before he kicks it, the ball is right here before he kicks it up. So the football is gonna go to the top of the goalpost, and it says the angle of elevation from the kicker's foot to the top of the goalpost is 17 degrees. I just read the first sentence and drew it piece by piece, because this is going to be a right triangle in the end, so you could just connect it and make a right triangle to see what you need to label. If he is standing 131 feet from the base, so the kicker is 131 feet from the base or bottom of the goalpost, how tall is the goalpost? Okay, so step 1, label my sides. Got opposite my angle is x. Hypotenuse isn't being used. Is not being used. Don't judge. And last but not least, adjacent. So yet again, OA, we're using tan. It won't always be that way, but so happened to be. So tan of 17 equals opposite is x over adjacent is 131. I'm finding a side, so I'm going to put the function over 1 and cross multiply. X is on top, so it's nice. We just do 131 times the trig function. When x is on top, we multiply. So if I put this into my calculator, I find that the football, well, the kicker is 40.1 feet away from, or no, I lied. I'm tripping while I'm sitting. All right, I'm sorry. That is how tall the goalpost is. See, it's good that we make sure what we're even finding. All right, so the goalpost is about 40.1 feet tall. All right, so what I want you to do is pause the video, try out number 3. Okay, so pause it now, and then we'll go over it. All right, hopefully you paused it. So let's look at this. Leah is standing at the bottom of the slide at the playground, waiting for Leah to slide down. So Leah is up on the slide. So we're just gonna say, okay, here's Leah. If she goes down the slide, if she goes up the steps, she's gonna slide down, that's our hypotenuse, to her mom. All right, so there's our triangle. I'm looking up. I'm the mom looking up at my daughter at the top of the slide, about to slide down to me. If the angle of elevation from the bottom of the slide to the top is 46 degrees, so she's looking up from her line of sight to Leah, 46 degrees. The slide has a vertical height of 9 feet. Vertical means up and down, so 9 feet tall is the slide. It says find the length of the slide. Well, the slide's not down here. We're not finding the base. How far is the mom from Leah? We're finding the slide that Leah's going to slide down, which is the hypotenuse. So now we're using something different. So, don't know why I changed colors. So this would be opposite over hypotenuse, sine of 46. X is on bottom, so you divide. 9 divided by your trig function, and you will get 12.5 feet. That is how long the slide is. Okay? All right, now pause it again and try out number 4. We'll go over it and then talk about depression. All right, let's talk about number 4. Hopefully you paused. I know I keep saying it, but I'm going to bug you. A dog is standing 5 feet from the base of a tree. Well, I can draw a tree. And there's a dog over here. I don't know if I want to try. I'm just going to say dog. Give me a little more distance, dog. All right. And he's looking up at a cat in the tree. So there's a cat in there that has climbed 16 feet up the tree. So the cat climbed from the bottom up 16 feet. What is the angle of elevation from where the dog is? So the dog looking up. It said elevation. That's key word. The dog is looking up at the cat. But it says what is the angle? So now we're actually finding the angle from the point the dog is standing on the ground to the cat. Well, first off, I missed something. A dog is standing 5 feet from the base. So I should have put 5 at the bottom. So 5 feet. Dog's 5 feet from the base of the tree. The cat climbs 16 feet up the tree. We want to find the angle the dog is looking up. So let's see. Opposite over adjacent. Oh boy, tan again. But now we're finding x, the angle. So now it's x in parentheses. 16 over 5. To unleash or get x out of parentheses, the opposite of tan is tan inverse. So I would do tan inverse. That's where you hit second tan, or it just depends on the calculator you're using. And in parentheses is your ratio. So tan, inverse tan, 16 divided by 5. So that means the dog is looking up at the cat in the tree at about 70.6 degrees. Okay? All right. So with that now, with that foundation, let's talk about angles of depression. So, angles of depression, the difference is okay, if you're depressed, you're feeling what? You're feeling down. So you're looking down at something. So here, when looking down to an object, the angle of depression is formed by the observer's typical line of sight. So the lifeguard is looking straight ahead by an observer's line of sight in the horizontal line. So this is his old line of sight, but now he's looking down at the swimmer. So now this is my angle. Remember, theta just means some type of angle. The angle of depression is congruent to the angle of elevation because they are alternate interior angles. So you might have chosen to draw a triangle this way. I think it makes the most sense personally, just because I see visually how I'm looking down at something. But if you chose to draw it this way, this is properties of a rectangle. Whatever this is, this would be the same. Whatever this length is, this would be the same. And they had said that's the same as alternate because of alternate interior angles. So if this is me looking down at the swimmer by alternate interior angles, I could also look at this green triangle. Whichever one makes more sense to you. I'm going to be drawing the one that's the black triangle most often, but notice the green triangle still works as long as you remember alternate interior angles And if the sides confuse you, remember properties of parallelograms, opposite sides are congruent. Okay? So let's get into this. It says, number 5. I don't know why I did that. I circled it, but I covered the words. So it says, a lifeguard is sitting on a platform looking down at a swimmer in the water. So actually, I think it's this picture right here. So if you want, you could just say, okay, I've got a lifeguard up here. He's sitting on a stand, right? You don't have to draw this. And it says that the lifeguard is looking down at a swimmer. So there's water. Here's the swimmer swimming. No, he's not floating. He is trying to swim. So the lifeguard is looking down at the swimmer. So this is his typical line of sight, but now he's looking down to see the swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground, so here this would be the above the ground. Well, parallel to that, this would also be 8 feet. So 8 feet here. The angle of depression to the swimmer is 18 degrees. So the lifeguard's looking down at the swimmer. His line of sight and then changing it to look down is 18. I'm sorry, the green might not be the best choice. How far away is the swimmer from the lifeguard? So this would be the distance from the lifeguard to the swimmer. But properties of rectangles, I can put X here as well. So notice there are 2 different types of triangles you can draw. The green, in this case, now I drew it green. This one I prefer. I just feel, to me, it makes more visual sense. But mathematically, alternate interior angles, this would be 18 degrees. Opposite sides, 8. This would be X. So both triangles will work to get you your answer. So I would label my sides. So now we're back to our usual. We have opposite, hypotenuse isn't being used, adjacent left. Go figure, tangent. So tangent of our angle, which they gave us, over opposite, equals opposite, which is 8, over adjacent, which is X. We're trying to find that side. Notice I said side. So since X is on the bottom, you take your constant, divide by your trig function, and what you get is about 24.6. What was it, feet? Feet. So the swimmer to the lifeguard, the swimmer is about 24.6 feet away until he reaches the lifeguard, or she. Okay? So it's the same idea, except now we're looking down at something. It's a matter of, does this triangle make more sense to you or the one below it? Just like what up above here when I talked about it, does this one make more sense looking down at something, or do you prefer having your right triangle in the same direction we've always been doing? That is up to you. So what I'd like you to do is pause the video and try out number 6. Give it a try. All right. So, excuse me, what you would have, a pilot and a helicopter spots a landing pad below. So, you would have, sorry, I got distracted, I heard something. So, I'll just write pilot, but he's in the helicopter, and he spots a landing pad below. So, I'll just put right here, X marks the spot to land. If the angle of depression is 73 degrees, so the pilot looks straight ahead, but then is looking down at 73 degrees to see the landing pad, to know how to start doing his mathematics, to know how do I land to that spot if I'm looking down 73 degrees. And the horizontal distance, horizontal left to right, distance to the pad is 1,200 feet. So yes, you may think, well, wait, I put my 1,200 feet down here at the bottom. Well, you're correct. Pilot to landing pad is 1,200 feet. parallel, if it was a rectangle, this would also be 1,200 feet. What is the altitude of the helicopter? Altitude means how far off the ground. So you would want to put it here, but if you're using the way I'm drawing it, if you put it here, that's fine, but by parallelograms and their properties, we can also put X here. Now, if you drew it this way in green, that is fine. Just make sure you have your 73 degrees at the bottom right, alternate interior, and you have your X and your 1,200. All right, so once you do the math, it is tangent, let's see, tangent of 73, opposite is X, adjacent's 1,200. X is on top, so you multiply them together. And we find that the altitude of the helicopter, how far into the sky it is 3,925 feet. And that makes sense. We'd want a large number to know how high off the ground. If it was really short, really small number, that pilot might crash on that landing pad. So this makes sense, so it looks good. All right, do not worry about 7. You will not have to deal with any kind of problem like that on the test, or the EOC for that matter. So last thing in this video is try out the very last problem, number 8. Pause the video and try this on your own, and then I will show you what I have. All right, now, it says Zach is standing at the top of a lookout tower and spots a water fountain below. So Zach is way up top, at the top of a lookout tower, and spots a water fountain. We'll just say water fountain. So his typical line of sight, but now he's looking down to see the water fountain. If the lookout tower is 75 feet tall, so if Zach, okay, this is the ground. If Zach is 75 feet tall, because he's standing on top of the lookout tower, so that means he is 75 feet above the ground. So you'd want to put it here. That's fine. But I'm using this triangle, so I do parallel. And the angle of depression, he is looking down 28 degrees. What is the horizontal distance between Zach and the water fountain? Zach to water fountain, right here. Maybe you put X here, 75 here, 28 degrees there for the other triangle. You're good. So let's see, we have opposite adjacent, so it's tan of 28 degrees equals opposite over adjacent. X is on bottom, so we divide. 75 divided by the function. And we get that Zach is about 141 feet, 0.1 feet away from the tower, or away from the fountain. Okay. And that is it. So, what your homework is going, oh, I'm sorry if you couldn't see that, I cut it off on you. So what your homework is going to be is to complete the flip book. Remember, I had you skip the application section. So I'm going to have you, now as a homework assignment, finish that flip book in the application section. That'll be your homework due the next day. All right, so now you have that applications part of the flip book. That is your homework. I believe there are 8 questions. All right, if there's any questions, you know how to reach me. Y'all have a good one.